Landboards presents Retro Computing Using FPGAs, Part Number 10. One of the really cool things about having an FPGA at the core of your computer is that you can easily add custom hardware and experiment with different configurations without doing a bunch of wiring. Here's the daughter card we designed for the top of our FPGA card, and on the card we put 3 headers with 8 I/O pins on it that go to the FPGA for adding custom hardware. The card is set up to run Microsoft Basic and use the SD card for storage. Here we're loading a program we wrote to blink an LED, and we added a register and hardware for that LED. The basic language program to blink an LED is pretty simple. Here's the LED blinking on the card under Program Control and Basic. Blinks at a nice little rate. We set it to blink 100 times in the code. Here's the start of the VHDL code using the standard libraries and defining the part pretty much like you would any 8-bit register. And here's the body of the code. It latches up data on a clock and a load signal, and the reset is reset by clear in the processor. The VHDL code also requires attaching the part inside of the microprocessor part of it itself. For that, we added the 8-bit I/O latch as IN OUT 8 at the bottom of the code here. This also requires adding a chip select, and the signal for the chip select is here as well. It's NSD chip select. And finally, for the Z80, it uses I/O writes and I/O reads to access the I/O space, so the decode is shown here as well. In Quartus, the pin planner is where you go to assign the pins. So here we've assigned the 8 output pins to 8 pins on the FPGA, which go to one of the headers. If you wanted to do this with an original computer, you would have had to purchase a 20-pin or so integrated circuit, and you would have had to wire it up with 8 wires to the microprocessor data bus. You would have also had to create some strobes, right to the chip kind of a strobe, and that would have required some logic to create that decode. It would have had to look at the address lines and the various select lines, and you would have also had to create an output connector for the 8-bit data output. A lot of work. And that's pretty much all that's required to blink an LED on an FPGA with a retro computer. I hope you get a chance to try one out. It's a lot of fun. If you want more information, you can see our wiki pages for these products, and we have YouTube videos on them as well. We have a store in Tindie where we sell all of these cards. Thanks for watching our video, and if you enjoyed it, don't forget to like, share, and subscribe.